My dear O2 students, in this video we go for the other type of geometrical transformation, which is translation. Translation is one of the transformations which is frequently asked in past papers you might have seen. Now I'm going to define it and have some examples for you. Translation. If an object is translated, it undergoes a straight sliding. It means that it just moves from a place to another place. So it means that orientation won't change as well as the size. So the shape remains the same, but in another position, in another location. That's it. So when you want to describe a translation, when you are asked, for example, you are given a shape which shows translation, so you are asked to describe the following, for example, geometrical transformation. So you need to mention, I told you for enlargement, questions have 3 marks, but in this case, questions have 2 marks. So what are the 2 marks given for? 1 mark when you mention the translation name. So translation should mention in the answer. The other one is vector of translation. Vector of translation shows that how many units as a vector. It is just the position, the location is changing. For example, here, as you see in this diagram, this triangle is translated onto this triangle. As you see, the lengths are the same. For example, base is 4 units, base is 4 units. Height is 1, 2, 3, 4, 5, 6, 7, 8, 9 units. Here is 1, 2, 3, 4, 5, 6, 7, 8, 9 units. If you notice, they are the same. But vector of translation. Consider 2 corresponding vertices. 2 corresponding vertices. For example, here to here. They are corresponding. They have the same position in both shapes. So now see what vector it is representing. 1, 2, 3, 4, 5, 6. So 6 units right. So the first component is positive 6, as you see here. Then how much it moves vertically? 1, 2, 3. So positive 3. You see, 6 and 3 is vector of translation here. The second one, now it is the original, it is the image, for example. Now, as you see, both of them are squares of length 1, 2, 3, 4. All of them, both of them are the same size. But what is actually the vector of translation? So consider 2 corresponding vertices. I consider, for example, these 2 ones. Do you see? These 2 corners at the right. So first, horizontally we count, as exactly we do for x and y vectors. The first component shows horizontal change, the second component shows vertical change. We do the same thing. So from here to here, 1, 2, 3, and 4, but negative 4 because you are moving toward left. So that's why the first component is negative 4. Then 1, 2, 3, 4, and 5. So positive 5 as you are moving up. Now, I would like you, as homework, do these 4 questions. I just explained the question. It says, in the following diagrams, object A has been translated to each of images B and C. Give the translation vectors in each case. So you have to express for each of them 2 vectors of translation. For example, one's A to B, one's A to C. I just, as a sample, I do one of them, A to B. For example, I consider this and this. These are corresponding vertices. So first horizontally, 1, 2, 3, 4, 5, 6. So negative 6 because you are moving toward left. But vertically, there is no motion. So the vector of translation will be negative 6 and 0. Now I would like you to do the rest and send it to me. Thanks for watching this video.